Sahara is a multi-tenant solution for building highly scalable and easily manageable software as a service on the Azure Cloud. First, I'll walk you through the Platform Administration tool, which allows you to manage your tenants, the underlying Azure infrastructure, as well as your third-party integrations. Let's get going. When first signing in, the dashboard gives you visibility into the newest accounts that have been registered into the system, the distribution of your current accounts, your sign-up statistics, any scheduled closures or recent closures, as well as billing issues that you may need to follow up on. Let's check out the accounts. The account section allows you to browse all the accounts or tenants within your system. You can search by ID, name, or associated Stripe subscription ID, and you can sort by date created, payment plan tier, past due, unverified, active, or inactive accounts. Every view in Sahara is responsive by default, allowing you to use any hosted components on any size desktop, tablet, or mobile device. When managing any account, Sahara aggregates your local data with your third-party data. For example, here is all the associated Stripe account information for this tenant. Under Basic Info, you're able to see which DocumentDB partition this particular account is on, as well as which relational SQL partition it has been designated. This allows you to leverage both NoSQL as well as relational databases, depending on your particular software needs. Each account also has access to flat file as well as blob storage. Key dates are on the right and include last activity logged. Our notification system allows platform admins to send messages to any user or user group on an account. Here I'm sending an important message to a key user. I can also set an expiration date for any message. Every account or tenant can have multiple users, and from the platform portal I can inspect and edit any one of them. Here's the notification history for the user I just sent a message to, including expired, read, and unread messages. It's important to note that the notification I sent this user was manual, but your business logic can also use the messaging system to programmatically send notifications and messages based on any criteria. Users and accounts can also send messages to each other. Every service in Sahara has methods available that can be refactored from their default state in order to power your own particular software requirements. Everything in Sahara can be logged down to any user action. Under the Advanced tab, we can see if the user is a member of any other account or an owner on any other account. We can also send them a password reset, as well as delete the user. Going back to our integration with Stripe, here you can see the next payment due on this account, as well as both payment and invoice history. Sahara gives you deeper insight into your Stripe integrations, allowing you to see the net profit on any gross income, minus the associated Stripe fees. You can also issue refunds directly from Sahara without having to log into Stripe. And the account owners will get a custom formatted email detailing the transaction. Aside from traditional payment plans with tiered access, Sahara also has a microtransaction engine that allows accounts to purchase credits that can be traded with other accounts or used to make purchases within the system. Account-level logging allows for deep historical insight into actions taken within an account and can be logged by category, activity type, or a particular user. Here we can get a visual sense of how much of the account plan's data allowances is being used, and how soon an account may need to upgrade to the next available plan. Using the Document Partitions tab, we can see how much of a shared or dedicated DocumentDB collection an account is using, including the types and amounts of documents being stored. We are able to do this by recording all JSON document calls using stored procedures and triggers on the server side using JavaScript. This metadata is saved in an account properties JSON document as represented here. It's easy to extend this to include new document types as your software evolves. Our partitioning manager, which we will look at shortly, ensures that accounts only use a certain allotment based on their payment plan tier, and also handles migrations to less restrictive partitions during upgrades. Managing relational data is similar. Here we can see the SQL assignment for this account, as well as a schema ID and the current schema version. You can manage rolling upgrades of schemas across the system, and each account has its own schema upgrade log. Platform-level logging gives you historical visibility into errors and exceptions from within the system, registration and account verification events, background tasks, billing events, application alerts, Stripe webhook events, and anything your particular software may require. Platform logs are categorized by category, activity, accounts, and platform users. You can also add origin and IP addresses into your logged item, as well as serialized objects such as an exception. The billing screen allows you to keep track of your Stripe balances, latest and upcoming transfers, credits available across the system, as well as reports on your balance transactions ranging from the last 24 hours to 120 days. You can also manage payment transactions and invoices made across all of your accounts. Managing your payment plans is easy. You can choose to hide a plan, adjust limitations, or delete a plan. You can also introduce new payment plan tiers, and the addition will be reflected in your marketing website, your account portals, as well as in your Stripe account. The platform section allows you to manage your Azure infrastructure, including your worker roles and your data partitions. The custodian worker runs at a set interval. 30 minutes is the default. It handles tasks such as account closures, timed reminders, data cleanup, archive management, and the often overlooked but very important art of dunning management, which includes expired credit card reminders, payment alerts, and initiates various customizable workflows to address accounts that have payment issues. There are also a collection of worker roles listening to message queues to handle real-time background tasks. Partition management is a key feature of Sahara, automating the creation, assignment, and migration of data resources for each tenant's requirements within your operating budget, maximizing profit and minimizing overhead. Using the Document Partitions tab, you can inspect the shared collections, their current capacities, and how your accounts are being distributed across each DocumentDB collection. Each of the default partition types, free, shared, and dedicated, includes a small legend to help you make sense of how your account's application data will take up the limited storage that Azure allows per DocumentDB collection. Migrations to larger tiers are handled by the Payment Plans Upgrade Manager. Shared SQL partitions are handled much the same way. During the onboarding process, Sahara will automatically place a new account into the next available partition and will spin up new partitions as required. For platform superadmins, there are even a few places where you can dive even deeper. For example, here's a management screen for your Redis caches. You can easily inspect the keys and hashes on each server, as well as flush the entire cache. Now that we've seen the platform administration in action, let's have a quick look at the account onboarding process. New accounts can register using the default registration website, which also works on mobile web. This view is powered by a registration API which can be easily leveraged to allow for registration through a native application platform such as iOS and Android. Once registered, the user will receive a verification email. Once verified, a provisioning task is sent to the background workers via message queue. When their account is ready, an email is sent to the user with login instructions. Each account is given their own unique subdomain for accessing the account portal. Let's log in as the new account and take a short tour. The default page is the dashboard, showcasing our data usage as well as a reference for API endpoints for our application data. Let's add some data to the account. By default, Sahara accounts have 3 data types that work together. Categories use relational data, tags are stored in flat files, and images are stored as JSON files in our DocumentDB database. This is sometimes referred to as a NoSQL approach. Using the image data type as an example will also allow us to showcase the imaging capabilities of Sahara. When writing your implementation, you'll likely need something other than categories, tags, and images, but each of these can be refactored for your particular solution. Out of the box, it's a nice way to showcase how Sahara can leverage the blob, flat file, NoSQL, and relational data types to create aggregated application data that is compartmentalized by tenant and cached on Redis for high-speed access. In future iterations, we'll also be introducing some machine learning components. This example showcases one way that we can aggregate data in Sahara. Here, our relational and flat data is represented inside of a NoSQL JSON document, which includes metadata used to describe an image on our blob storage account at this location, as well as its asset variations. And everything is tied back to the associated tenant or account ID that owns the asset. Let's quickly add a few categories, subcategories, tags, and images. Notice as I'm cropping images that I'm locked out of some additional features since I'm on a trial account. Image enhancements require an upgraded account, so we'll revisit this in a moment. Sahara allows you to easily place features and add-ons behind a paywall or payment tier, as well as entice users to upgrade. As you can see, we've reached some of the limits of our trial account and are being prompted to upgrade, which we will do shortly. You can see this visually back on the account dashboard page. And here is the same data that a platform admin would see back on the platform portal. Also note that this account is on a free tier for its document database, meaning it can only have 20 documents, in this case images, in a collection shared by 10,000 other accounts. This keeps our costs very low, especially on accounts that are not paid. Whenever a transaction flows into the system to create, edit, or delete an object, or take any action on an account, it passes through the request validator, which checks the user's access privileges, the account status, and any plan limitations in real time. This allows Sahara to inform the user why a particular action may have failed in order to resolve it with a plan upgrade or a role modification. You can also set your own rules. For example, you may want to deny any account that is past due on their last payment to make any changes on their account until the account has resolved any lapses in payment. Back at the account portal, we can now see our data in action. Here we can see the document data represented as images being filtered by both relational as well as flat table data. It is important to note that all data is cached by Redis servers and is called directly, avoiding extra hops through our service layer or to any data stores. Whenever content is edited, added, or deleted, the Redis cache is immediately updated for read-only traffic to benefit. Since this is a trial account, let's upgrade to one of our payment plans and increase our account capabilities. All account owners are alerted to the upgrade via email. And since this tenant now has a payment method attached to their account, an associated customer is created on our Stripe account. As you can see, the account has migrated from the free document tier to the shared tier, allowing it to have about 50,000 documents on a collection shared by only 50 other tenants. There is also a dedicated tier, which allows a single account to have well over 2 million documents on their own private collection. Now that we are upgraded, we can take advantage of image enhancements. Let's see them in action. You may have noticed when I was adding images to the account earlier that I was locked out of using the image enhancement sliders, and was prompted to upgrade to take advantage of this feature. You can do the same with almost any feature upgrade that your particular software will offer. In addition to cropping, we can now sharpen, adjust the colors, and apply simple filters to our uploaded image assets. If your software requires audio, video, or other media types, this can also be implemented. All of this work with large media files is done using intermediary storage for the raw assets. The custodian worker, which we discussed earlier, also has a cleanup routine that will garbage collect this for us in about 24 to 48 hours. Now that a credit card is associated with this tenant, we can also make microtransactions on the account. In this example, we will purchase some credits and then spend them on a one-time service. We can also trade credits with another account. The credit transactions log is there to help keep track of any historical actions and resolve any disputes. Account admins are privy to all the activity logs for their account, and it can be made available all in one place. They can drill down to a particular category, action, or user. And every user can manage their own profile, including adding an avatar or image. Let's log out of the account portal and quickly go over Sahara's architecture. Sahara at its core is a centralized grouping of components that manage all transactions requiring authentication or validation. Composed of worker roles, web roles, table storage, blobs, queues, document, and SQL databases, this is the core transaction engine where your shared business logic lives. It is also ready to be migrated to the new microservices framework that is expected to come out of preview in about 1 to 2 years. Whenever a new component is spun up, such as an API or a front-end application, it makes an initialization call to core services in order to get relevant information, such as application settings, endpoint URLs, and private keys. It also offloads any important transactions or processing tasks back to core services when required. Core services can be scaled up, as well as scaled out, based on your performance and traffic needs, as can each of the complementary components. All data is backed by Redis caches, minimizing backend calls and increasing performance. The caches are isolated between platform and account data and can also be scaled up when your traffic peaks. And everything can be set to automatically scale back down to save costs during non-peak hours. Sahara integrates with Visual Studio Online. All components are checked into a Git repository and separated into logical projects, making it easy to integrate a development team of almost any size. It also integrates with the build system and allows you to manage as many environments as you require. This was a quick tour of the Sahara ecosystem. As you can see, Sahara allows you to focus on what makes your software unique, and not the underlying infrastructure or standard features that users expect from a cloud-based SaaS solution. Feel free to contact us with any questions, and thank you for your time.